Okay, so welcome everyone. So I have been asked to present a little bit of Sagemath, which is a free open source software to do mathematics in general. Roughly, you have with Sagemath a Python interface to interact with a lot of open source packages like NumPy and SciPy, of course, but also Matlab, Maxima, Gap, Flint, Paris, and a lot more. The first release was 15 years ago. We have a large community of developers for Sagemath. The source code of Sagemath is roughly 1 million lines of code, plus the packages, so it's a big software. Okay. And you can do a lot with Sagemath. You can play with numbers. So you have, of course, integers and also rational numbers inside Sagemath by default. So you don't have to ask for something else. You have to know that Sagemath has a preparser for all the commands. So you don't, what you type in a console or in a notebook will be pre-parsed to support extra syntax and to understand if you are playing with rational numbers, with integers, with real numbers, or so on.
Extra syntax over what?
I did not get the question.
Maxime was asking extra syntax over what?
It's the R something is something about real numbers. It's one of the difficulty I have with Sagemath. There are so many stuff that you can do that I'm not aware of everything. I know that this syntax is possible, but I don't know what it means in this case. I'm sorry about that.
Okay, no, my question was extra syntax, but what's the... enfin, en français, je veux dire, c'est la syntaxe additionnelle, mais par rapport à quelle syntaxe de base? D'un autre langage?
I'm not sure you can do that in Python.
Ah, par rapport à Python. Ok. Pardon, c'était vraiment la question. Okay.
Because the basic language is Python, and you have other languages like Python, C, and C++ behind. And I will come back to that later.
Okay.
So I first show some examples of what you can do, basically. So you can play with integers, of course. You can play with rational numbers, real numbers, complex numbers by default in Sagemath. You can do symbolic math as well. So you can declare a variable x, and you can declare functions and do mathematics with these functions that are symbolic computation. So you can have the integral of a function. You can simplify it. You can multiply a function by another, compound them, and so on. You can also plot these functions. You can have functions with one or several variables, also for symbolic computations. So this is possible. You can solve systems of equations also. Like you can do that also in Matlab and Mathematica. So this is possible inside Sagemath. You can do, of course, numerical mathematics. There is a huge package behind also for number theory. So you can play, by default, the integers, they are with the GMP library. So you have very long integers, and you can do arithmetic with them relatively quickly. You can get the factors of a large number very quickly. You have also by default different rings, so you can check if a number is rational, or if it's a real number, or if it's an integer, or if it's a complex number. You can do arithmetic with complex numbers. Okay. You can do linear algebra as well without importing everything because it's already inside. So you can play with matrices, get the kernel, the eigenvalues, and so on of matrices. There is a big package on combinatorics because roughly the research community on combinatorics is using Sagemath by default. They code everything inside Sagemath. So there are many functions to do combinatorics. There is also a big module for graph theory. So I'm one of the main contributors for this module. Inside, you have plenty of generators of graphs. You have a lot of functions. Some of them actually are only interfaces to network-X when the network-X function is very good. Otherwise, we have our own implementations. And we have also interfaces with library like Boost, iGraph, and so on. There is also a basic interface to do some linear programming. Here you have a small example of a linear program that you can solve. And for the solver, by default, we have GLPK and another one, which is PPL. PPL is weird because it's an exact solver, so you can solve a linear program with rational numbers and get the exact solution. But it's slow. We have also interfaces with Simplex and Ruby and other solvers. What else? You can display graphs. And here is an example of a graph with 10,000 nodes that we displayed using D3.js, which is a JavaScript interface. And also something that is interesting inside Sagemath is that it relies a lot on a language called Cython, which is an hybrid language between Python and C++. Roughly, Cython will compile the Python code, which may contain some C code inside. And then you can use functions that are much more efficient. So for instance, here I have several blocks. One is a function, so test.py is a function that is pure Python. Okay, you can use it like that. But then I have in a C file the same function in C. Okay. And then I have this file test.pyx, which is the extension for Cython files. Inside, I can load the function from the C file. And so I can call it. But I can also write a pure Python method. I can write a method in Python plus some type declarations, like in C. So it's a cdef long s, means that you have a long variable. And when you check the performance, it's not easy to read, but the pure Python method is the slowest. And if you take the Python method that has been compiled with Cython, then it's faster. If you, of course, declare the type of the variables, then it's even faster. And if you use the pure C method, it will be again faster. So it's something interesting when you have critical methods to implement. You can implement them in Cython and get better performance. Okay, so it's a brief overview of all you can do with Sagemath. Then to interact with Sagemath, you can use either a Jupyter notebook, or you can go directly on a console. And each time you have an object that you are using with the completion, so tab, you get access to all the methods. And here you can see that for graphs, there are plenty of methods. Okay. On here and also on the notebook that you have on the web page, there are several useful links. So the main web page, the web page for the installation instruction, the reference manual, where you have a lot of documentation. And we usually try to put a lot of details inside the documentation. There are also plenty of tutorials that you can access. There is a free book that you can download. And some interesting links are ask.sagemath.org, where you can ask questions about to get help about coding in Sagemath. If you have bugs, you can use the appropriate mailing list. That's it. So if you want to get started with Sagemath, either you install it on your laptop, or there is an alternative, which is to go on cocalc.com. So Cocalc it's a company, but they offer free access to use Sagemath online. It's relatively slow, but okay. And the company has been funded by the guy who originally started Sagemath. So he offers a lot of options to use Sagemath on other software. So now maybe you can start using it and ask questions about what you are trying to do. No? What do you think?
Vous voulez qu'on fasse un peu joujou?
Ouais.
Allez, faisons joujou. Alors, I admit that I didn't install it for the moment, so I need to do it.
So the installation process may take some time because it's a huge software.
I didn't do my homework before the working group.
Is it bigger than Anaconda, for instance?
And I have a question in the meantime. How do you compare with Network X in terms of performance? Because some Network X functions are very slow. So do you improve on some of them, or it's more about adding new features?
It's not very difficult.
How do you compare? It depends.
Okay.
No, the answer is not easy because Network X is pure Python.
Yes.
Here, for graphs, we have a lot of methods that are in C.
Okay.
So when it's in C, usually it's faster.
Okay.
There are also methods using linear programming inside. So if you use a good linear programming solver, then you have good performances. No, it's not easy to say if it's always faster or always slower. I think it depends on the method.
Okay, but could be.
But for instance, you can handle graphs with more than 100 nodes. So you're better than Network X, basically.
Yeah, you can have large graphs.
Yeah.
And then Barabasi, I can have 100,000 nodes. Of course, it's not instantaneous, but I have my graph. Then I can compute its diameter. And it should not be too slow.
Are you using the exact diameter algorithm or something like the one from Habib or I don't know?
It's exact. we have several algorithms, but the default one is DHV, which is the Dragan-Habib-Vienno algorithm.
Oh yes, it's exactly when you do the yes.
Yeah. So we don't need to do the whole pair shortest path.
And out of curiosity, what are the inner representations of graph that you use?
Oof.
A lot of them, or just one of them, or you just
The main one is we have our own C library, which is 15 years old and that has been improved a lot, but it's still. So the problem is that for graphs, it's always the same problem. You want them to be mutable, so you want to be able to add, remove vertices. You want them to allow or not loops on multiple edges. You want them to have weights on the edges. You want them to have various kind of labels, and so on.
And each feature has a cost.
On each fish, yes, exactly. You want them to be dense or sparse. So we have different data structure because the default data structure is for sparse graphs that are mutable, but you can also have immutable graphs. You have dense graphs as well. And from time to time, we have to convert to another format to have access to faster methods. But it's inside. Usually for the user, it's you don't see it.
For instance, the decision to switch between sparse and dense, it's made on the fly or something like that. I don't know.
So so you have the graph constructor. You can say when you build the graph here, you can say if it will be sparse or not, immutable or not.
Okay.
And then you can convert. But when you convert, you have to change everything inside. So I think it returns a new graph. Oh, and for graphs, we make no assumptions on the labels of the vertices as long as they are of an hashable type.
Yeah.
So it is possible to have immutable graphs as vertex labels.
Oh, you can hash the immutable graph. Yes, of course. Yeah. It's kind of oops.
Yeah.
We'll also use Coudert, yes, if you don't want to install it.
Yes, but almost done.
On if you want to add an edge, you can do an edge between 1, 2, 3, and then you have the label of the edge if you want. It could be either an integer or it can be a dictionary of something. For the label.
David, I have a question about you talk about Jupyter. I am using Jupyter Lab. Do you know it is possible to use directly Sage in Jupyter Lab?
So you can do this. So you can launch Jupyter from Sagemath. And then I have to switch the window.
The question is, can you use Sagemath from Jupyter?
Yes.
I'm not in the right place, in the correct place.
Oh, yes, it's okay.
Yeah, looks reasonable.
Does it answer your question or not?
Yeah.
In fact, it is Jupyter, and I use the web interface Jupyter Lab. I know it is, in fact, it is based on what they call kernels, and I don't know. I will look by myself in the website of Sage in that case. But I do not use Jupyter like you use it. In fact, I use directly Jupyter Lab.
Yeah, but if
Ludovic, logically, if you install Sagemath, then where you're in Jupyter Lab, you will be able to choose the kernel you want. So either you choose Python 3
But
kernel.
yes, but you need to my question was, is Sage usable as a kernel in Jupyter Lab, in fact?
I guess so, because as David just showed, it's possible in Jupyter, so it should be possible in Jupyter Lab.
Yeah.
Okay.
If the kernels are registered, they should be registered for all API.
Yeah.
Okay. It was my question. I do not use all the details for how Jupyter Lab is working, so I will check by myself anyway.
Yeah, it should work.
I think,
it should work. I know that they are planned to remove Jupyter and use Jupyter Lab only.
but, the people talk about that for since many years now, so I'm not sure it will happen.
No, it's book for either.
They are discussing it more and more. There was emails this morning on the mailing list.
Okay. Okay. But I found the Jupyter Lab more usable for me, but it's a personal opinion. People may have other ideas.
Well, actually, I only use Sagemath with the console.
Yeah. But if you want to do some presentation, including some calculation using Sage, Jupyter Lab is a good way to do it. Or Jupyter notebook, classical notebook also.
Yeah.
Yeah, because you can use Rise with Sage, I believe, with a notebook. Because Rise is on the Jupyter side, not on the.
You should.
Yeah.
Restarting something.
For me, I'm not sure I will have finished installation before the end of the workshop. But François, I believe.
Ouais, il faut juste que j'arrive à le faire marcher maintenant. Je fais ça, il se passe quoi?
Non, mais Jupyter Notebook, vas-y, tu crains des gains, ça va marcher.
Je l'ai fait déjà, mais.
Ok. So Stack Overflow, on va utiliser kernel Sage.
C'est ce que j'étais en train de regarder. Ta.
How to install Sagemath kernel. Okay, il y a une commande.
Also, if you are curious, inside the notebook, I gave example because there are also efforts to work with Latex.
Wow.
So you can have nice output.
Okay.
And you can get the LaTeX code from time to time.
Are there advantages in using Sagemath over Matlab, Mathematica, Maple? I mean, other than its accessibility?
Well, I think the fact that it's open source and free is already an advantage. Otherwise, I don't know.
Yeah, I know that there are still the big Maple community for exact computation. He's a huge fan of Maple, and Chile as well.
I have a question.
Yes.
Maybe to bounce on the previous one. How easy is it to plug Sagemath with other Python modules? Like, let's say I want to use PyTorch to do some deep learning, and I want to use also Sagemath. Is it possible to write programs that plug Sage data structure to other Python libraries? Or is it like you work in Sagemath, you stay in Sagemath?
So I think what you ask for is possible, but difficult. Usually you stay with Sagemath and you use it as your instead of Python.
Okay. It's somehow a world of its own.
Yes, somehow. And you can install plugin using pip with Sagemath.
Okay.
Actually, this raises another question for me. If you take a working Python code, will it work straightforwardly in Sage or not?
I think so.
But maybe not if you're using like.
Which kind of
I don't know, imagine I've got a Python module of my own and I want to install it in Sage. I just do Sage setup install, I don't know.
you can try that, yes.
Yeah.
Maybe with other options.
Also, it's something I looked at during the installation, the numbers. The Python version is currently 3.7. Can you switch your Python version inside Sage or not?
No.
No. It's bonded to be a 3.7, which is the next update. Okay.
I don't think you can. Usually it tries, when you install Sagemath from source, it will try to use the Python version you have. But there are so many dependencies inside Sagemath that they try to control the version you use.
I had another question, which is kind of a meta question. Do you know how Sagemath became a success in some sense? I mean, how did the community build, and how, yeah, because I was thinking, for example, of people here at Lynx who tried to who build a package in Python called Scikit Network. So they did this beautiful package implementing various algorithms on graphs, and with especially focus on being performant on large graphs and so on and so on. But in fact, now the problem that they have is that, okay, the PhD students who did the code left, and it's very difficult to have people work on maintenance of the code, because it's very cool to implement new things, but maintenance is a very ungrateful work.
Yeah.
So do you know how from a little seed of a project the things grew and survived since more than 15 years?
From the seed, I'm not sure. I was not there at the time. But there was a community of mathematicians who were motivated to do computation without paying license to Matlab and Mathematica.
Okay.
So they developed something on their own. And then some community started to work with them, with this tool, like the combinatorics community. And also something that is interesting is that for the graph library, it's constantly improving. So at first, they were relying a lot of NetworkX, just doing some interface. And slowly, it has been replaced by internal code, proprietary, the code that is inside Sagemath. But the fact that if there is a function that is very good using an external library, then we have an interface for this library and we use it. For instance, there is a library called Noti that is very good to enumerate graphs. So we have an interface for this library. There is Clicker, which is very good to find large clicks in a graph. So we have an interface for that.
Because, for example, so I believe Sagemath, so Sagemath uses some Cython, if I understand well.
Yes.
And in fact, from what people from Scikit Network told me, in fact, for example, Cython is a bit a hell for maintenance because as soon as Apple launches a new processor, you have compatibility issues about the compilation of Cython code, and in fact, there is a lot of maintenance work that is simply due to external factors, and that needs a lot of work. That is not very exciting because just it's just maintenance, not new stuff. And so for Sagemath, it's just a community of benevolent people, or there is a kind of an engine in the
it's a community of benevolent people, but they have benefit from European projects some years ago.
Okay.
They were able to obtain a large amount of money from Europe. It was about a project about improving the universe around Sagemath. So not only the core library, but also working on different packages that are used inside Sagemath. So for instance, the Paris library got money from that European project. Yeah. So this library. It has boosted a lot the development of Sagemath, and also some gives money to improve the maintenance, to improve the architecture of the system.
Okay. And
also, so what you have to understand is that some years ago, Sagemath had a lot of issue with compatibility when you install it on different computers.
Okay.
So it was coming with its own GCC instance.
Okay.
At that time, you had to compile GCC inside Sagemath. And slowly, so it's no longer the case, hopefully. And now we rely more on system packages.
Okay. And so maybe you won't have all the answers to my questions, but so when there was this big amount of money spent on available for Sagemath and related packages and stuff, so typically how this money was used, it was for example PhD students or for system engineers, engineers in general, or
Mostly engineers.
Okay.
It was a big project with something like 30 or 40 partners.
Okay.
And the money was used to pay some engineers
Mm,
and to have regular meetings for the coordination of the project.
yeah. Yeah. That's a bit what I thought, that at some point you really need engineers.
Yes. And we have also some feedback from Cocalc because they use Sagemath,
Yeah.
but they don't contribute a lot to the open source part.
Okay.
That's true.
Okay.
From time to time, they come, they say, okay, to do this, it's better this way. And also, since almost 10 years now, each year we go to Google Summer of Code
Okay.
to have some students working for Sagemath during the
Okay.
summer. And it's how we have implemented some complicated functions inside Sagemath. Always give a boost. So if you want to decompose a graph into 3 connected components, it's now possible because we have implemented the algorithm by Targent during Google Summer of Code.
Trying to do 3 plus 5. Ah,
This is a notebook?
this is a Cocalc.
Ah, oui. Yeah.
Ah, no, c'était pas le. It was not the operation that was slow. It was just the instantiation, because the second operation was okay.
Ouais.
Ouais, it works. Well, finally, I went to Cocalc because I would have to check on Stack Overflow to put in place the interaction between Jupyter Notebook and Sagemath on Windows.
Yeah.
Alors, on y va.
I finished the extraction of files. There's a lawnmower somewhere.
I don't know. Yeah, does someone shred papers near you, David? Or
What?
we hear like a lawnmower or a strange noise, but maybe it's not. Maybe it's not you. Maybe it's somebody else in the meeting. I will mute Ludovic just in case.
Ah.
I was muted.
Really?
Someone said it was in.
Alors, par exemple, j'essaie de faire 3/4 is in queue. Is it true? Yes.
Yes, it's true.
Yes.
But as you can see, Cocalc is quite slow.
Yeah, but for the moment, I don't ask fancy stuff. Okay.
You can also pay for it, but it's not what you want to do.
I will. So pi to the pi to the pi to the pi is not in cube, apparently.
Pi is not in Q.
Sorry?
Pi is not in Q.
Apparently. And pi to the power pi to the power pi to the power pi is not in Q either.
Because it could be. Square root of 2.
I think we cannot compute precisely enough this pi to the pi to the pi to the pi.
Yeah, in fact, I had the vague notion that there was a question about this particular case, but
I remember watching a video about this one, and they were saying there's not enough computation power in the world to answer the question.
Yeah, you can compute.
Hop, magie.
What magic?
The cos of pi over 3 is in Q.
Yes.
But by the way, you mentioned SymPy, but for me, I used a bit SymPy and it was really slow. So I guess that the symbolic computation in Sagemath also rely on other pieces of software, not only SymPy, I believe, or.
I also believe so, but I'm not completely sure what they use.
Okay.
Should be explained inside the reference manual.
Yeah. Graph theory.
Yeah. And you have a lot. But roughly what you want is this one, generic graph. And you have all the functions that are for graphs and digraphs. Which means adding edges, of course, checking isomorphisms, checking. Yeah, we have to improve this page. There are also tools to do some interactive plots.
J'ai rajouté une clique. Ça claque. C'est beau. J'ai rajouté une petite clique là.
Yes, you can add a click inside a graph.
Yeah, that's what I just did.
You can add a cycle.
Allez, j'ajoute un cycle. Paf.
Yeah.
Another list of the vertices that the cycle to be added.
And some people have fun with animations. Oh.
Tac. fois 9. Bah,
So you have a click on the cycle.
and there's just no, I was just yeah, checking how you can define your own function in a Python style and.
If you define the function for Python, like add a kayak, add
Yes.
I remember from time I used Simpy that it was very fast to derivate function symbolically. But
Yes.
much harder to integrate. Why integration is much harder than derivation?
In fact, for at least for usual functions and so on, for derivation is very easy because
Just apply the rules.
you just compose rules.
Yeah, but why fundamentally? Because I mean, you could expect that they are very related to the right. One is the reverse of the other.
Like in RSA.
Yeah, like exactly like a reversing the hash function. Hashing is easy.
Because you're losing information.
Not
Losing information, I would not say so, because as you told, if
you lose a constant.
I think that's not the main issue, in fact.
Well, it's just that you've got maybe 10 basic rules for derivation, and if you want to infer from one type of function where to look the type of integrate,
Yes.
then the number of rules grows exponentially or something like that. Yeah. For instance, when you've got the integral of tangent, where you have to, okay, it's 1 divided by 1 equals t2. Oh, I recognize that one. I use this technique. Okay.
Essentially, when you have the abstract syntax tree of an expression, you can already program the derivation very easy, because just take the top node. You just take the root of the abstract syntax tree and recursively apply the rule.
But yeah.
And for integration, it's not like that, in fact.
Yeah. I understand.
For example, if it's even if you think that it's a composition, so it's you have something like G prime times F prime of G. But for example, if your expression is a product of 10 factors, yes, it's not clear how you will split it.
Yes.
To have the G prime and to have the F prime of G. You see what I mean?
Yeah, you have a lot of combination.
Yeah, you have a lot of combinatorics that you don't have that you don't have when you derive, in fact.
Yeah.
And sometimes for integration, you don't even have the possibility to express the integral with usual functions, by the way.
Yeah.
Just to show something fun.
Yeah. Woo!
It's something we used a lot when I use Sagemath to address the Flinders Hamiltonian cycle project. Because normally you can, of course, it's not working today. Normally you can zoom inside the graph and modify the graph and play with it. And to have this, you just need to, it's a simple line. There is a small interface to do so.
Show method égale JS. I will try. Does it work on CoCalc? I will see.
I have not tried actually.
I don't think it works on CoCalc.
Maybe not. Or maybe it's too slow.
Yeah, maybe.
You can get the TXZ code of the graph.
Cube graph. I try cube graph. Huh?
How do you get the TX code of a graph?
Latex of G.
Graphs.
Does it also work for function plots and so on, or only for graphs?
I did not get the question.
Does it also work for function plots, or just for graphs? Like if I plot a function and I want to have the TX code, can I get it?
This I'm not sure, but you can get it in TXZ. You can try.
Yeah,
Because when you ask for the LaTeX code of a function, you get this. It's not, and when you want to plot, you have this, but I'm not sure. You can plot the function, but I'm not sure we can have the LaTeX. We can try. No. Actually,
it is. It's working. I think so. It's giving me some LaTeX. If I do LaTeX of plot of f, it's giving me some.
It gives some LaTeX.
Some TX code. Then I don't know if.
Yeah.
Actually, but if it works, that's very cool.
Ça a l'air. Hein. Moi, ça a l'air de donner des trucs raisonnables.
Il y a beaucoup de lignes de tech, alors ça doit être.
C'est ça. C'est.
No, but they had fun with LaTeX. There is also a package called sagetech.sti, so that you can embed some LaTeX, some Sagemath code inside a LaTeX file. I know it's possible, but don't ask me how.
But what does it do? Does it print the output?
It means that inside your LaTeX file, you can have some computation.
Okay.
I'm not sure it's really useful.
I was seeing that there is this Europe map in the graphs.
Yeah.
And and in fact, when I try to use show on that graph, it's a bit messy. And I was asking if there is a notion of yeah, of a static position or a graph being really naturally embedded in the Euclidean plane or something like that.
Yes, because so writing it, you can get the position of the vertices for some graphs. Apparently, I'm missing something. So, yeah.
Okay. Okay.
So, when you have a grid graph,
okay,
it's because when we build it, we assign position already.
Yeah.
So you can get these positions.
Okay.
For Latex, you have and you can also set positions, but then it will ask for if you look at the documentation of the method, it will ask for a dictionary of positions.
Okay.
So you can pass a dictionary.
Okay.
And if you want, actually, the dictionary is here. So you can interact directly with the dictionary if you want.
Yeah, but it's bad because there is an underscore. I don't want to do such things. It's really dirty.
It's bad.
I have ethics.
Yeah, I've got a kernel notebook.
Bravo. Et donc, tu as réussi à le kerneliser dans le notebook?
No.
Tu as réussi à ouvrir Sagemath et ouvrir Jupyter à partir de Sagemath?
Yeah, I've got. So if I do 6.
Donc, du coup, c'est Sagemath qui a ouvert Jupyter ou l'inverse?
So actually, the story is there is no Windows version of Sage, so it's running over Cygwin.
On Cygwin, yes.
So you just have, so if you want to install the notebook extension, something like that, you got to do this on the Jupyter Cygwin version.
Okay.
I've installed on Windows Sage on my side. So
yes, but under the hood, it's actually using Cygwin. To be honest, I would recommend people to use Windows System Linux.
WSL, yeah.
Yes.
Okay.
Probably be much more efficient.
It's right for me. It's not clear that it was using this kind of thing.
Yeah,
I just try it very quickly. It works in shell command.
Yes, but when you want to install the notebook, you realize that the two worlds are totally not connected.
Separated, yeah.
Okay. It was my initial question. I will investigate more this. But the installation of Sagemath took a long time. In fact, I've just succeeded a few minutes ago, and I started 10 minutes ago, more than 10 minutes ago.
Okay.
But I will investigate it because I think it's something that interests me. In fact, and if you have some possible conversion with LaTeX, it's also something very interesting. In my opinion.